Buffer solutions are simply mixtures of a weak acid and its conjugate base. In this case, we have our bicarbonate with our carbonate. Weak acid, conjugate base. Okay? So, you'll have to do more than just identify them. Oftentimes you have to do a calculation. You calculate the pH of a buffer solution. Well, buffers are just weak acids, so they're not unique in that sense. But when buffer solutions are being prepared, typically you're dealing with adding a certain concentration, certain amount of your weak acid together with a certain amount of your weak base. So you're actually adding a reactant and a product to start off the system. So where that becomes an issue is when we're doing our calculations. So in the end, I'm trying to find pH. That's my task here. pH equals negative log of hydronium, which means I need to figure out the hydronium at equilibrium. Well, since it's a weak acid scenario, it means I am going to have to use a K value. We've already identified before when we're trying to find pHs of weak acids and weak bases, we should, or most often, we'll be able to use our approximation rule, which means we can go right into our shortcut. However, with pHs, we don't want to go right into that shortcut. And that shortcut I'm referring to is where we utilize the square root of Ka times the acid concentration. Okay, don't use that. But we will start a similar way in that we want to write out our equilibrium law. So Ka is products over reactants as normal. Okay, with a normal weak acid, I would square my H3O because we usually say that the products are equivalent to each other. Well, only thing to remember with a buffer is you just don't square them. Just leave them alone and plug in your numbers as they are. So in this case, we know the Ka from our data table is 4.7 times 10 to the negative 11. H3O would be our unknown. Carbonate was given as 0.0025. And bicarbonate was given as 0.10. So when I rearrange all that and isolate H3O plus, I end up with a value of 1.9 times 10 to the negative 9 moles per liter. That could be the end of your question. If it's not, don't round that value. Leave the complete unrounded value in your calculator and plug it in to your log formula and solve that. We get a final answer of 8.73. Just one other thing to remind you, don't forget about the significant digit rules with pH. I have 2 significant digits in my concentration, therefore that equates to 2 decimal places in my pH.